time.
Yeah.
Why do you exclude the human albumin?
That's actually a very good question. Okay, albumin. So albumin will work as a colloid, right? And somehow it will expand the plasmatic volume. Now the problem with albumin is that if a patient has a traumatic brain injury, albumin will actually go through the barrier and will increase cranial pressure. Now you will say, well, but what is the relationship between one and the other? Well, the relationship is that almost 30% of troops that have been shot in battle also have some kind of traumatic brain injury associated. So it's a very high percentage. It's almost 30% of them. So not to risk giving albumin to a patient who already has a traumatic brain injury, non-diagnosed, albumin has been more or less excluded, at least in the military setting, as a first line. I mean, it can still be used. I mean, there is still a role for albumin, of course, as a plasma expander in other circumstances. But when we're talking about penetrating trauma in conflict, I would probably keep it out.
Any other question?
Okay, so you have to bear with me for one more presentation. Sorry. Okay, I would say that probably to make things right, this should have been first, and then the other one. I'm going to talk to you a little bit about ballistics and essential ballistics. So we started in the end. We started by saying, what do we do when someone is actually injured by a bullet, let's say. But I didn't tell you anything about bullets. And I find it very curious because what I realized today is that many people in the military, although they are in the military, they don't really understand exactly how bullets work and what is the effect of bullets in the tissues, and the type of damage that they can cause and why do they cause this kind of damage. So I think that talking a little bit about ballistics is always good. So when we talk about ballistics, we can talk about medical priorities and we can talk about the physics itself. I would go a little bit on both, a little bit about medical, a little bit about physical. And when you think about injuring agents, you have bullets from handguns and you have bullets from rifles. And we also have bombs and missiles and mines. I'll concentrate mainly on the bullets. I may say something about mines later on. So just to be sure that we're talking the same language here, this is a rifle, okay? So when I say a rifle, I'm referring to something that looks like a Kalashnikov or an M16 kind of rifle, okay? The Kalashnikov is one of the best ever produced in the world, and by the end of the presentation, I would say that if one day I will be shot, I wish is a Kalashnikov, at very high range, but still a Kalashnikov. Very stable flight for the bullets, and you will see why. Now, if we're talking about handguns, we're talking about basically pistols and revolvers. So if I say a rifle, you think Kalashnikov. If I say handguns, you think police pistols. That's what they use. Now, what you see here is not a bullet. It's a cartridge, okay? So the cartridge basically have different areas. So you have So you have the bullet on top. You have a case. You have powder inside, and you have a primer, which is basically an explosive here. The bullets from the handguns have exactly the same composition. Actually, the cartridges are exactly the same. So you have bullets, you have a case, powder, and primer. The big difference here is the amount of powder. Okay? So here you have a lot of powder. Here you have much less powder. And you will see it makes all the difference in the future. Now, the old bullets were made of lead. And as the technology on making powder evolved, the kick was so strong that the bullets would fragment immediately on leaving the muzzle, because there was too much powder and it was just lead. So they decided to jacket the bullets, basically to put a copper alloy around the bullet, so that the bullet would not be destroyed just by the powder when leaving the muzzle. Okay? Later on, they realized that these bullets, they were not actually being very effective in taking someone down. I mean, if a soldier was running to you and would be hit by a full metal jacket bullet in those days, they thought, I mean, the guy keeps on running even after I hit him. So they thought about ways to make these bullets more lethal. And the way to make the bullet more lethal was basically to create a semi-jacketed bullet where it's not covered here on the tip. And I will show you why this makes such a difference. Now, the most famous of these semi-jacketed bullets was called the British Mark II, that was producing Dum Dum in India. And so today we still use the term Dum Dum bullets when we refer to bullets that are semi-jacketed. It's not the correct term, but everybody understands when I say, oh, probably it was a Dum Dum, means that it was a semi-jacketed bullet. Now, semi-jacketed bullets have been prohibited to use in conflicts by the 1899 Hague Declaration, that prohibits bullets that expand or change shape from being used in armed conflicts. And you will see why this is so important today. Today's bullets, officially, that can be used in military are full metal jacket bullets. Okay? They can have a hard core to penetrate an armor, or they can have a tracer if you want to shoot at night. But anyway, they're all full metal jackets. Okay? The Dum Dum bullets are still used for hunting. So if you want to go to a hunting shop, this is the kind of bullets that you will find. These are semi-jacketed or hollow point bullets, and they are only used for hunting because, in theory, if you want to kill an animal, you want to kill it with one shot, right? And so these bullets produce maximum damage. On the contrary, the other ones produce more limited damage. So to avoid unnecessary suffering of human beings, the Hague Declaration was basically subscribed so that you don't provoke unnecessary suffering. Now, just a quick overview for those who haven't seen the process or how it works. So as I told you, you have a case full of powder and you have a primer on the bottom. So this is your primer here, and this is your powder or propellant, whatever you want to call it. And then on top of it, you have the bullet. Now you have different types of bullets for depending what you want to hit, and the ones here are all for hunting. The idea is that when you load the bullet, there is a firing pin that hits the primer. So the primer is a very unstable explosive that ignites and then ignites the powder and produces gas, and the gas propels the bullet. Now, in order to gain stability in flight, the muzzles are made in a way that when the bullet flies, it twists so as to gain maximum stability. However, if from a macro perspective it looks like the bullet is flying straight, the truth is they don't fly straight. And if you look at the tip of the bullet as it flies, this is the movement that the tip of the bullet is doing. Okay? So the more it flies, the more stable it becomes. Okay? So that's why I said I prefer to be hit by a Kalashnikov at 200 meters, because it's much more stable than at 50 meters. Okay? 50 meters you still have high angles of attack, but at 200 meters bullets became more and more and more stable. Now let's go back to the energy, because the interesting thing about bullets is that all we're doing is we're playing with energy. If you see the mass of a bullet, okay, let's take the Kalashnikov one, 7.62, which used to be a NATO standard. The mass is very, very small. This is an 8-gram bullet. It's more or less the same weight, the bullet itself, as a 9mm bullet, a 9mm bullet that is used by police forces here in Greece, for example. Okay. So they more or less have the same mass, the bullets, but the velocity that they gain when they exit the barrel is completely different. This one goes 700 meters per second. This one goes 350 meters per second. Now, because the equation is basically the square of the velocity, you get very high energy on rifle bullets, and you get quite low energy on handguns. Okay. And this is the basics for everything that comes after it. Okay. Because it's all about transfer of energy. So we are transferring the energy in the powder to the human body through a bullet that will fly with that same amount of energy. Now, of course, when you transfer energy to a tissue, you have tissue damage. And bullets will probably give you lacerations, shock waves, temporary cavitations. I'll show you all now so that you understand how this energy is transferred from that initial powder through air to the human body. If I shot 7.62 Kalashnikov bullet on a gelatin block, what I get is this. This is a standard rifle bullet. It's the most used all around the world. Most conflicts around the world, this is what they use. Okay? Now what we just saw here, and I'll replay again. What we just saw here is a huge temporary cavity. You saw? Huge expansion. A big temporary cavity being produced. Now this was a gelatin model, so as it expanded also collapsed. Now, the human body doesn't behave exactly like that, but the same cavity is created when you are hit by a rifle bullet. So, when you have a rifle bullet going through the human body, basically what happens is that for the first few centimeters, the bullet goes straight. It's what we call the narrow channel. Now, after a few centimeters, the bullet already released a lot of energy. It goes into the more stable position to travel, which is sideways. So they go like this, and they turn sideways, because that's how they release most of the energy. Now you think, why do they turn sideways? Well, think about leaves falling from a tree. How do leaves fall from a tree? They don't fall like this. They go like this, right? That's the more stable position to release energy. So bullets turn sideways. So they go straight, they go through the narrow channel, and then they turn sideways. And when they turn sideways, they release most of their energy. And so they create this huge temporary cavity. Now here, we are shooting on a soap block. So soap is plastic somehow. So once you create the temporary cavity, it does not collapse like the one we saw in the gelatin. Now, this is the basics for everything that comes after when we talk about small entry wounds, big exit wounds. Most of you would say, yes, we all know that when you're hit by a bullet, the entry wound is the small one and the exit wound is the bigger one. Well, I'll show to you that it's not always like that. Okay? So imagine that this is more or less the thickness of my arm. If this is my arm, I would have a small entry and a small exit. More or less the same size. Yeah? Now, if instead of my arm, I was being shot in my leg, which is a bit thicker, I would probably have a small entry and a bigger exit, because that's at the point where the bullet is already tumbling. Okay? If I'm being shot at a very long distance, and this is like 100 meters, the bullet already lost a lot of energy during flight. So when it hits the body, it doesn't have much energy to release. So it creates a small temporary cavity and then releases all the energy, and that's it. So this is the Kalashnikov long distance shot, the best one, okay, believe me. And you can actually have, in these cases, a very small entry and a very small exit also, and a lot of damage in between. Why were dum-dum bullets prohibited? Because a dum-dum bullet has a completely different behavior when it hits the human body. A dum-dum bullet will enter, and in the first 2 centimeters will basically deform, will release all the energy on the first 2 centimeters. And what you get is a huge entrance wound, huge cavity being created immediately as it enters. So the bullet doesn't explode or something, okay? It just releases all the energy immediately. And so if this was my arm with a dum-dum bullet, I would have a big entry, a huge exit, and probably an amputation, because everything in between is gone. Okay? And if this was my leg, I could actually have a big entry wound and a small exit wound. So just looking at the wound size doesn't tell me anything about what was the entry, what was the exit, because you can have big entry, small exit. It happens. Okay? Now, in most conflicts today, and especially in urban settings, what we see is ricochets. A lot of ricochets. And this is true, I would say, yeah, almost everywhere. I mean, unless you're being targeted with a sniper, in most cases, there are a lot of ricochets. On the walls, on the ground. And what happens with the ricochet bullet is that it completely loses stability after the ricochet. So usually enters the body already sideways. And it creates a wound that it's very, very similar to the one caused by the dum-dum bullet. Now, because of these, a lot of allegations have been done in a lot of the conflicts around the world that, oh, that army, they are violating the rules of war because they are using dum-dum bullets. Look at these wounds. Actually, those wounds were caused by ricochet bullets, not by dum-dum. The only way you have to demonstrate that a dum-dum bullet was used is if you find one. If you don't find one, it's a ricochet until otherwise proven. Okay? So no allegations of that. Now, we do see a lot of these. Why were they banned? Because if you hit the bone with a 7.62 full metal jacket bullet, you'll have a hole here, you'll have a hole there, but you still have all the periosteum there. So it's like, I mean, the periosteum works like if you put a bottle, a glass bottle inside a sock, and you break with a hammer, I mean, the whole glass will fragment, but the sock is still there. So the periosteum for the bone works more or less like that. I mean, periosteum gives the nutritional support for the bone. So if you're hit by a full metal jacket bullet, you have a fracture, yes, you still have a fracture, but you have a lot of periosteum. I mean, if you debride, if you take all of these pieces of bone out, which are dead bone, because this one will not do anything unless, I mean, it will only infect. If you take everything out, this bone probably will heal nicely. Now, if you're hit with a semi-jacketed bullet, it's not only the bone. You need to imagine that next to the bone, you have the major artery, and you have the nerves. And so as the bone went off, all the nerves and arteries again went out. So with this one, you get a fracture. With this one, you get an amputation. And this is the main difference between both of them, and that's why these ones have been prohibited. Now, 2 minutes, yeah, I'm finishing. Now, interesting enough is that a lot of countries in the world, well, not a lot, I would say, a couple of countries in the world are developing bullets that they don't deform, but they are stable enough to fly straight, and as soon as they hit the body, they start tumbling. And so they would have exactly the same effect as these ones, although they are still within the limits of the law, unfortunately. Yeah. So just to show you a few cases to finalize, this is a small entry, small exit, a lot of bone inside, and you clearly understand that this is what happened. Small entry, small exit, it's just the narrow channel that you got here. Another case, small entry, quite small exit, but a long distance between both. So I know I'm not in the narrow channel, I'm already there. So in this case, the temporary cavity actually happened within the chest. The curiosity about this guy is that this is an open chest wound. As he was talking to me, I could see the lung. inside. And everybody says, oh, open chest wounds, you need to immediately close. This guy had been shot 2 days ago. Okay. So 2 days ago he was shot, and he came to me saying, I have something here on my back, and it was an open chest wound, and that was it. Crazy. Another situation, you have small entry, a slightly bigger exit, and if we know a little bit about ballistics, we know this is what happened, okay? Small entry, slightly bigger exit. So I don't expect from here to there, I don't expect any of these. Okay? I know that if I debride well the channel, this is what I'll find. Another case, small entry, much bigger exit. I know that I'm there. Small entry, big exits. Very curious case, 2 shots, 2 parallel shots, going side by side, 2 small entry, 2 big exits. And there's no way you can miss it. It means that this is reproducible. So the same small entry, big exits on 2 parallel shots. Kalashnikov in auto mode. Now these ones are slightly different. You have bigger entries and big exits. So what happened here? Ricochet. I heard ricochet. Ricochet. Okay. Big entry, big exit. And here? Big entry, even bigger exit. The same. Ricochet. Every time you have a ricochet, you have big entries. Okay? Exits can be bigger or smaller, depends. But big entries, usually, if no one is using dum-dum bullets, it's ricochets. Just to finalize, handguns, police handguns. They behave exactly the same way, so they go straight. They don't have enough energy to create temporary cavities. The difference between both is that the semi-jacketed bullets that the police actually uses create bigger injuries than full metal jacket bullets. So most of the police departments around the world in Europe today, they change to the semi-jacketed, the one who causes more injury. And then we'll say, wow, how come? Why is police using a bullet that causes more injury than others? Well, there is a simple explanation for that. The full metal jacket bullets, the 9mm from the police, would penetrate something like 1.2 meters. The semi-jacketed bullets only go 30 centimeters. Why? Because if you're shooting in a crowd, you don't want your bullet to hit the guy you're targeting plus the guy who's behind you. Okay? So that's why they changed to a different kind of bullet that, yes, creates a slightly bigger injury, but doesn't hit the person standing behind you. Okay? Thank you.
Thank you, Dr. Nelson. Any questions? Okay, no questions. Thank you again for your presentation. Thank you very much.
Any questions? No?
No.
I didn't have the chance in the beginning to thank Professor Antopoulos for the invitation, but thank you very much. This is it's late, but it's better late than never. So still, thank you for that. Thank you.